Hello everyone, welcome back. So today we are going to study about the reactions of alcohol. Before studying the reaction of alcohol, we will learn about the acidic nature of alcohol. So give the heading acidic nature of alcohol. Right here, acidic nature of alcohol. Acidic nature of alcohol. Right. Now, if you see or if you have basic information or have basic knowledge about what is an acid is a compound which has the ability to donate proton when it dissociates. So if alcohol is ROH, when it will dissociate, then it should give RO minus and H plus, right? Now the reaction will proceed in the forward direction only if this negative charge or the products are stable, right? So when product is stable, then only reactions proceed in forward shift, right? Now if you compare the stability of 1 degree, 2 degree and 3 degree alcohol, when we take 1 degree alcohol, let us assume it is CH3OH. Now when it will dissociate, right, it will give CH3O minus plus H plus, right? Now we know CH3 is a plus I group, right? That means it will push the electrons towards O minus, right? And if you see the 2 degree alcohol, it will be CH3, here will be one H, here will be one CH3, here will be OH, and when it will dissociate, it will give out CH3 H CH3 O minus plus H plus, right? Now here if you see there are two H plus CH3 groups present, that means more inductive effect, that means more electron density is increasing on this oxygen, right? Hydrogen is not an inductive group, right? So presence of more CH3 group is making the electron density on the oxygen more. Now if the same thing happens for the 3 degree alcohol, it will be like this: CH3 CH3 CH3. This is the example of a 3 degree alcohol. Okay, this is CH3OH. Now when it will dissociate, I am doing it downwards, it will become CH3 CH3. The C will be here, let's make it a bit clear. It will be CH3 CH3, right? It will be C, it will be O minus and H plus. Now see, if you see this group, CH3, number of CH3 present is 3, and CH3 we know is plus I group. It will make the electron density on the O more dense. As a result, this product will be very unstable compared to this one and this one. So we can write that 1 degree alcohol, so if you write the order, so we can write the order as 1 degree alcohol is more acidic than 2 degree alcohol and 3 degree alcohol. Okay, acidity. Why? Because here the electron density on CH3O minus is small, not like this one or this one. That means this is comparatively more stable than CH3, or when the CH3 is coming in 2 degree or in 3 degree, right? That means this is more stable, this is a little less stable, and this is the least stable. So as a result, this product has a very less tendency of formation. Okay, so for this the acidity of 1 degree is more than 2 degree and more than 3 degree. If you want to remember the acidic strength, you can keep this in mind, acidity, that acid strength is inversely proportional to plus I group. If plus I group is increasing, acidic strength is increasing, and if plus I group is decreasing, acidic strength is increasing, like this. Okay, so copy it up to this much. After this we will learn about the reactions with active metal. Now we will study about the reaction with active metal. Now you have to remember this thing, that acid plus any metal which has to be active metal, which is the group 1 or group 2 metal. Okay, so acid plus metal which will give you salt, and H2 as gas, not water. Acid is not so much strong that it will give salt plus water, but acid plus metal gives salt and hydrogen. So if you take example of this like this, if you take C2, if you take C2H5OH plus any metals, if that is sodium active metal, it will be C2H5ONa, which is the sodium ethoxide, plus H2 will be liberated as gas. Okay, now if you want to take any other metal, let us take magnesium, C2H5OH plus Mg, it will give C2H5OMg plus H2 as gas. Clear? So this was about the reaction of acid with active metal. Next we will study about the reaction with metal amides. So let's do it in this place. So let's write reaction with metal amide. M stands for metal. Okay, so when we study reactions with metal amide, you have to remember that acid plus metal amide will give you ammonia. If acid plus, or you can write alcohol also, acid plus metal amide will give you or liberate ammonia as gas. Okay, now under this, if you want to see few examples, it will be like this. When you take C2H5OH, which is ethyl alcohol, plus metal amide, let us take sodium amide in this case, it will be NaNH2, it will give C2H5ONa, similarly C2H5ONa plus NH3 as gas. Clear? Now if you want to change the alcohol to methyl alcohol, like this, CH3OH plus NaNH2, then it will give CH3, then it will give CH3ONa plus NH3 as gas. Clear? Clear up to this much? Now we will study about the reaction with aqueous alkali. So let's clear out this portion of the board. Reaction with aqueous alkali. Now alcohols are not so much strong that it will give salt and water with alkali. Okay, let's write here aqueous alkali. Alkali are nothing but bases. Okay, so we know a fact that acid plus alkali always gives salt plus water. Now note a point that alcohols are not so strong that it will yield salt plus water with aqueous alkali. Right, that means if you think the reaction like this, C2H5OH plus NaOH, if you think that it will give you C2H5ONA plus H2O, C2H5ONA plus H2O, this is a completely wrong thing. Never try to understand this is a correct thing, because alcohols, I said in the beginning of the chapter that alcohols are weak acid. Alcohols are not so much strong that it will react with the strong alkalis or aqueous alkalis to give you salt plus water. But there is an exception under this category. If you take methyl alcohol, I said methyl alcohol is stronger, right? If you take methyl alcohol and you treat it with sodium hydroxide, which is the NaOH, now it will give C2 now it will react and give CH3ONA plus your H2. Clear? Now this is a very important exception. They can ask you. Normally alcohols do not react with alkalis with to give salt plus water, but there is an exception that methyl alcohol will give C2H3ONA, I'm sorry, and water, because it is a strong alcohol, right? So copy it up to this much. Next we will study about the reactions, about the esterification of alcohol. So let's clear out this portion. Give the heading esterification of alcohol. Right here, esterification. Esterification means formation of esters. Esterification, which means formation of alcohol, right? Now you have to remember that carboxylic acid or any acid plus alcohol, it reacts to form an ester. So if you want, you can write carboxylic acid plus alcohol, it will give ester. Now to match with this equation, if you take any carboxylic acid is like this, RCOO. This is the structure of carboxylic acid. When you treat it with alcohol, which is R dash, which R dash means a different alkyl group, so it will react and give you an ester. Now this is a reversible process, so you have to write this way. It will be RCOO, this will be OR, this will be R dash. Clear? And along with this, you will also get your H2O, which is a water. Now if you use, now since you see this is the reversible reaction. Now if you use concentrated H2SO4, in this case the reaction will occur in a forward shift. That is now right here, use of concentrated H2SO4, reaction occurs in forward shift. Forward shift means in the forward direction. So if you take the similar reaction, okay, if you take the similar reaction, or let us take another reaction with the help of few examples, right? So if you take like this, CH3 C double bond O single bond OH plus, if you take any alcohol, let us take methyl alcohol, CH3 OH, right? When you take concentrated H2SO4, when you take concentrated H2SO4, it will give you like this, CH3 C double bond O CH3 plus H2O, right? Now this is called methyl ethanoate, right? So copy it up to this much. Next we will study about the rate of esterification. So this was about the few acidic nature of alcohol and the reaction with metalamide acidification. Now we will study about the reaction due to the presence of or the cleavage of ROH bond. So let's keep the heading this side. Reactions due to cleavage of ROH. That means the OH group will be removed. Right? So under this category, if you see over here, the first thing which we count here is the Lucas test or the reaction with hydrogen halide. Okay, so right here, reaction with hydrogen halide, or you can write it as Lucas test. Lucas test I will explain separately after this. Okay, so let's see about the reaction with hydrogen halide. So if you get an alcohol like this ROH, hydrogen halide you can take HCl. Now you have to treat it with anhydrous ZnCl. So anhydrous ZnCl2, right? And it will give RCl plus H2. See, this OH group is breaking and Cl is getting added over there. Clear? And if you take sulfuric alcohol like this, and take an example, CH3 over here, and this is OH, and when you take or react it with HCl in the presence of anhydrous ZnCl2, ZnCl2, this OH is being removed, Cl will get added, so we will get tertiary butyl chloride, okay, or 3BP right plus H2. Okay, clear to this much. Now we will study about the Lucas test and the Lucas reagent. So let's clear out this portion of esterification so that I have space. So let's write over here Lucas test. Okay. Now this HCl and anhydrous ZnCl2 is called the Lucas reagent. HCl and anhydrous ZnCl2 is called your Lucas reagent. So to perform Lucas test, we will treat any alcohol with Lucas reagent, and if a precipitate is formed immediately, then it is a 3-degree alcohol. If after 10 to 5 minutes the precipitate is formed, then it is a 2-degree alcohol. And if no precipitate is formed after any amount of time, or a precipitate is formed after infinite amount of time, that is, the precipitate is never formed, then it is a 1-degree alcohol. So you can say that this Lucas test is the process of identification of the type of alcohol, whether it is 1 degree, 2 degree, or it is 3 degree. So right here, if it is 3-degree alcohol, if it is 3-degree alcohol, if you treat it with Lucas reagent is this. Okay. So if you treat it with Lucas reagent, then you will get RCl as precipitate plus H2O. Then you will write instant. Okay. Instant. And if it is a 2-degree alcohol, if you treat it with Lucas reagent, you get RCl. After 5 to 10 minutes, okay, and along with this you get water. And if it is 1-degree alcohol, you again treat it with Lucas reagent, you have no precipitate. Reaction will occur, but no precipitate is formed. So this can be used as a methodology for the identification of the type of alcohol. What is Lucas reagent? Writing here, what is Lucas reagent? Lucas reagent, or L in this case, is HCl or hydrochloric acid concentrated. Along with that, we take anhydrous ZnCl. Clear? So this was about the Lucas test, which you can do to perform the identification of the type of alcohol. Now, just remember that this is the white precipitate. Okay, white precipitate. Clear? So, copy it up to this much. Next, we'll have a similar sort of reaction, not the Lucas test, with HBr. Now, if this is replaced with HBr, okay, so let's clear out and make it with HBr. Okay. If this is filled with HBr. Now, let's take C2H5OH, C2H5OH, right, we'll fill it with HBr. Now, here we have to take acid. There I taken that HCl, but we can take here concentrated H2SO4. So what will happen is C2H5Br will be formed. C2H5Br. This is a similar sort of reaction as that one, but this is not Lucas test. Lucas test is performed with anhydrous ZnCl2 and concentrated H. Right? Now you have to keep another thing in mind when you treat it with HBr. Okay, C2H5OH. When you treat it with your HBr, HI, this is a different sort of reaction. Then for that case, you do not need any catalyst. Because see, I is a strong leaving group. I have a tendency to leave easily because of its large atomic size. So there is no need of any catalyst or any agent to speed up the reaction. It will already leave or come. Right. So this was about the reaction about the cleavage of ROH bond. Now let's take a question about the conversion. The question is preparation of ethane from ethanol. Preparation of ethane from ethanol. If you want, you can write. Question is conversion of ethane from ethanol. Ethane from ethanol. Ethane is C2H6. Okay, you have to get from ethanol. This is C2H5 ethanol. When you treat it with HI, you get C2H5I. But when you take HI along with red phosphorus, it is a strong reducing agent, so it will directly give you alkene. Okay. Sorry, it will give alkene. So if you take HI and if you treat it with red phosphorus and iodide, it will give C2H6. So along with this, you will also get one more. Right? And this iodine will come out as 9. So this was an interesting question about the reaction of alcohol due to the cleavage of ROH bond. So copy it up to this much. After this, we will come to the reaction of phosphorus halide with alcohol. Copy it. Of with phosphorus halide means phosphorus with any halogen compound, including bromine and iodine. So let's take the example. Okay, so let's take the example of reaction of C2H5OH with TCl5. This is phosphorus pentachloride. Phosphorus pentachloride is a phosphorus halide, right? So when C2H5OH or your ethyl alcohol reacts with phosphorus pentachloride, it gives C2H5Cl plus POCl3 plus HCl, right? And if you take phosphorus trichloride C2H5OH with phosphorus trichloride, it will give C2H5Cl plus. Along with this, you will get H3PO3. This is H3PO3, right? Now, this was about the reaction with chlorine. Now, when it becomes iodine or bromine, if it is PBr3 or your Pi3, then the reaction will be something of different type. So, if you see the example again, C2H5OH, and you take either PBr3, not both, okay, or you take Pi3, okay. Now, along with this, you will get only C2H5I or C2H5Br. So, C2H5I or you get C2H5Br accordingly. If it is Br, then you get C2H5Br, and if it is Pi3, then you get C2H5I. So, this was about the reaction with phosphorus halide. Now, we will learn about the reaction with thionyl chloride. Now, we know thionyl chloride is SO2Cl2. Now, let's see what's happening on reaction with thionyl chloride. So, let's rub the board. So, give the heading reaction with thionyl chloride. Just a minute. Reaction with thionyl chloride. Now, this reaction we are already familiar with. This reaction is the reaction we have already studied in the haloalkane chapter. It is the Darjan's process method, or you can call it the best method for the preparation of any alkyl halide. So, let's see what was there. That we take any alcohol which is ROH, we treat it with SO2Cl2. This is the thionyl chloride which we are talking about in this case, and we get as a result of this RCl plus SO2 plus Cl2. Now, if you remember, SO2 and Cl2 are in gaseous state. Now, if you remember why this was the best process, this was the best process because all the byproducts, that is the SO2 and the Cl2, are in gaseous state. So, we get RCl as a byproduct. So, if you see any example in this category, let us take the example of C2H5OH, ethyl alcohol, with your SO2Cl2. SO2Cl2, we get C2H5Cl plus SO2 sulfur dioxide in gaseous state and your chlorine as gaseous state. Okay, so this was about the reactions of about the cleavage of your ROH bond. Now we will study about the dehydration of alcohol where we get alkene. Now we are quite familiar with this in the class 11 chapter. We have already studied in the alkene chapter. So let's recap or recapitulate or revise what you call, whatever you call, and see what's happening there. So let's clear out the board. Okay. Give the heading dehydration of alcohol. Give the heading dehydration of alcohol. Dehydration of alcohol. Okay. Now, under dehydration of alcohol, it is the process of removal of water. If you remember or try to remember the previous year concept, it was the alpha beta elimination which actually happens here. That is, if you take any alcohol, let us assume R, CH, and here you have your CH2, and with this carbon you have your OH. Okay. Now, what happens here is, here will be another OH. Now, if you see, I told it about the dehydration of alcohol. Now, dehydration means removal of water. Now, see, if these two things are removed, OH and H, it will be ultimately resulting in the removal of water, because see, H and OH means H2O. So, if you give some reagents over here, reagents I will list out afterwards. If you give some reagents over here, as a result of this, these two things are coming out, and as a result a bond will be formed here obviously, so it will become an alkene, RCH double bonded CH2, right? So this is the basic fact or the basic thing which is happening in the dehydration of alcohol. Now you have to remember that the ease of dehydration is depending on the stability of the carbocation. So you can write over here, ease of dehydration, ease of dehydration is directly proportional to stability. Just a minute, let's write it a bit downwards. Ease of dehydration, ease of dehydration is directly proportional to stability of carbocation, right? So this was about the dehydration of alcohol. Now let's discuss what are the reagents which can be used for the dehydration of alcohol. So the reagents are the products which can be used for the dehydration purpose of your alcohol. I'm listing out the reagents over here down by down. Okay, so the possible reagents can be give heading possible reagents. Okay, so possible reagents under the number 1 we have the obvious thing, which is concentrated H2SO4. So right here concentrated H2SO4. After this we also have H3PO4, which is the phosphoric acid. So it is H3PO4. Now after this, in the third one we have the KHSO4. Okay, so let's write KHSO4. Now after this they will give you many they will give you Al2O3, number 4 Al2O3, P2O5, and it can be also be your pyridine. Okay, so let's write here P2O5, and it can be also your pyridine, PYRIDIN, right? Now you have to write some notes in this category. Write the notes below this one only. The type of elimination which occurs here is the E1 type of elimination. You have already studied E1 type of elimination. Okay, and Cbse rule is being followed here. For the right product or the major product, we follow the Cbse rule. Now to understand this, we will follow the example after this. After explaining this Cbse rule follow. Right, now after the Cbse rule is followed, you have to write that obviously the carbocation formation is taking place because ease of dehydration is dependent on the stability of the carbocation. So obviously a carbocation formation is being taking place. So carbocation formation. Okay, now we will understand this Cbse rule and carbocation stability. Carbocation, just a minute. Carbocat. Okay, so carbocation formation is taking place. Now we will understand this entire thing by the help of an example where I give you a question, and you have to tell me the answer. What is the product and the minor product and the major product? So let's see the question under this. Okay, so let's erase this portion. So my question is, we take CH3, CH2, and another let's take CH2, and here you take CH2OH, CH2OH. Okay, now when you treat it with, let us assume, concentrated H2SO4. So this is concentrated H2SO4. Now when you take this compound and you treat it with concentrated H2SO4, what is the product form? Now take your time and answer the question. Take your time. Pause the video and do it. Done. Now it's a quite obvious thing that you will say that the answer for this thing will be like this. It will be CH3, CH2, CH2, and after this there will be 1 2 3 4 1 2 3, and there will be double bond CH double bonded CH2. Now it's a quite obvious thing that this is your answer, but this is actually not the major product, this is the minor product. Now how this is happening, this is the minor product. Okay, how this is the minor product, now this I am going to explain. Now see, here I have mentioned that E1 elimination is taking place, okay, and carbocation formation is taking place. Okay, now if you keep in mind about the stability of carbocation, okay, stability of carbocation I am writing over here. Okay, it is 3 degree more stable than 2 degree more stable than 1 degree. So this is the stability order of your carbocation. Now I am going to explain why this thing is the minor product. So let's clear out this portion. Let's clear out this portion and see why this one is the major product. Okay, so let's see the mechanism what is happening. So my compound was this one, so it was CH3, CH2, 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 and here was my OH. Now when you treat it with concentrated H2SO4, okay, now what does H2SO4 do? H2SO4 will bring out this H2 and this OH, right? So as a result of this, we get this thing as an intermediate CH2, CH2, 3, CH plus, and here will be CH2, and just a minute, CH2, here will be CH2 plus. I'm sorry, here it will be CH2 plus, right? Because one hydrogen is coming out, taking the electron as water, so you can also write here minus H2, so water is being coming out. So but see here, this is a 1 degree carbocation which is comparatively less stable than the 2 degree carbocation. Now if you notice this compound here, there is a possibility of 2 degree carbocation is occurring if the plus charge is coming here. So there will be 1 2 hydride shift. See, this is 1, this is 2. So if this plus charge is being shifted over here, that means there will be a 1 2 hydride shift, which will result in the increasing stability of the carbocation from 1 degree to 2 degree, right? So you can write here 1 comma 2 H plus shift. So if this H plus is shifting here, it will be converted to a 2 degree structure. I am writing this 2 degree structure, CH3, CH2, CH2 plus, and here will be CH, I think it will be 2. This will be 3, I'm sorry, right? Now after this, the question arises, on which side will the double bond be formed? Double bond can also be formed this side and also be formed this side, right? Now if you apply Cbse rule now here, now according to Cbse rule, it says that the product which is more stable will be the major product, and the product which is less stable will be your minor product. Now to find out the stability of the product, we will count the number of hyperconjugative hydrogen. Now for doing the product type answer, first we will write the structures of all the possible type of product. So from this two type of structure is possible, right? So one type of structure I am writing over here, this is CH3, CH2, CH2, double bonded CH2. This will be one product, right? This will be my one product, right? And my another product, if I remove this, okay, if I remove this, my another product from here will be CH3, CH2, double bonded CH, double bonded CH, and here will be CH3, right? This is the but2e and this is the but1. Now if you see and count the number of hyperconjugative hydrogen over here, you will see this one has more number of hyperconjugative hydrogen, so this one will be the major product, Okay, and this one will have the lesser number of hyperconjugative hydrogen than this one, and so this one will be the minor product. So I'm writing here minor product, right? See, this one is this one, right? So you have to do nothing, you have to just follow the mechanism. When you add concentrated sulfuric acid, at first the water is being eliminated, as a result of which a 1 degree carbocation is being formed. So you can write here 1 degree, and this one is 2 degree. So, and there is after the formation of the 1 degree carbocation, there is a possibility of the formation of a 2 degree carbocation by the 1,2 hydride shift. So after that, the 1,2 hydride shift is occurring, and then after that double bond is being attached, and both the sides the double bonds are attached, but the product which has the maximum number of hyperconjugative hydrogen, that is the major product, and the product which has the less number of hyperconjugative hydrogen is the minor product. So this was about the dehydration of alcohol. So you can copy it up to this much. After this we will move on to the further sections. Okay, so now we will begin with the oxidation of alcohol. So let's begin. Give the heading oxidation of alcohol. Oxidation of alcohol. All right. So oxidation of alcohol can be done in various ways, and it will give different types of product depending upon the type of reactant used. So if you take, for the first case, if you take acidified K2Cr2O7, which is the potassium dichromate, or you can take the KMnO4, which is the potassium permanganate. Okay, now for this case, if it is 1 degree alcohol, okay, if this is 1 degree alcohol, then it will be converted to your carboxylic acid. Okay, it will be converted to your carboxylic acid. If this is 2 degree alcohol, it will be converted to your ketone. Okay, no aldehyde is being formed over here. If this is 1 degree alcohol, it will be carboxylic acid, and if it is 2 degree alcohol, then it is ketone. Now if you take 3 degree alcohol, it has no effect. 3 degree alcohol on oxidation, it has no effect. Don't write here that aldehyde is being formed. For 1 degree alcohol, there is carboxylic acid. For 2 degree, there is ketone, and for 3 degree, there is no effect. So if you want to see an example, I am doing it over here. Let us take a 2 degree alcohol. Okay, first 1 degree alcohol, then 2 degree C2H5OH plus KMnO4. If you take acidified KMnO4, what will be formed is C2H, or you can write it in this way, which is the CH3COO. This is the ethanoic acid or the acetic acid, whatever you call, both are the same thing. Okay, now if you take a 2 degree alcohol, okay, let us take like this RCOH, and this is R dash. So when you take K2Cr2O7, let us take in this case acidified K2Cr2O7. Okay, now for this case, ketone will be formed. It looks like this RC double bonded O single bonded R dash. Okay, this is an acid, this is acid, this is your ketone. Right. So this was the reaction with acidified K2Cr2O7 or KMnO4. Now we will take another list of reactions for which we get aldehyde. So let us erase this portion. Okay, let this number 1 remain as it is. Let us erase this examples. Okay. So under the first thing which we have is the red hot copper tube. Cu means copper tube. The third thing which we have is is here PCC, which is the pyridinium chlorochromate. After this we have Jones reagent, JONES, Jones reagent. After this, we have another thing which is called the Collins reagent. Okay. After this, we have the Sarrett's reagents. Sarrett's reagent. Right. After this Sarrett's reagent, we have the MnO2. But before this, let us do another thing which is your NBS, which is the N-bromosuccinamide. And another thing, and the last we have, let's write over here, it's haloform. Haloform. Number 9, you can write also MnO2, but only for benzylic alcohol. Putting a star and writing benzylic alcohol means there has to be a benzene group attached. So benzylic alcohol. Right. So from 2 to this number 9, if the alcohol is 1 degree alcohol, then it will give aldehyde. If this is 2 degree alcohol, then it will give ketone, and if it is 3 degree alcohol, then as usual it will have no effect. So putting a box here, and then I will connect with arrows. One arrow, let's do it in an organized way. So one from N-bromosuccinamide, one from Sarrett's reagent, one from the Collins reagent, Jones reagent, pyridinium chlorochromate, red hot copper tube, haloform, and the end it is MnO2, which is the only for the benzylic alcohol. So this was about the oxidation of alcohol. So you can copy it down. Done. So with this we come to the end of the chemical reactions of alcohol. In the next video we will start with the processes of preparation of your phenol. Followed by that we will study the chemical properties of phenol, and then as a result in the end we will end the chapter with one video of it. So thanks for watching. We wish you all the best.